Hey, welcome back. All right, let's talk about the foundations of continents, starting in the Archean. All right, so let's first talk about shields. Okay, I'm not talking about Captain America. I'm talking about geologic shields. So continents consists of rocks with composition similar to that of granite. Typically, continental crust is granitic in nature. Continental crust is thicker but less dense than oceanic crust, which is thinner and more dense, and that's usually made up of basalt and gabbro. But these shields of the Precambrian, these geologic shields, consist of vast areas of exposed ancient rocks, some of the oldest rocks, and are found on all continents. So shields are exposed old rocks found on all continents. Outwards from the shields, the exposed stuff, are broad platforms of buried Precambrian rocks that underlie much of each continent as well. Okay, so you get these really, really old rocks. If it's exposed, that's called a shield, for instance, the Canadian shield. But then that material extends out and is covered, and that's, well, not the shield. That's called the platform. But those old rocks, those basement rocks, the oldest rocks that make up the shield are below the buried sediment, right? Dirty weathering and erosion, stuff gets put on top, right? So the exposed oldest rock is the shield, and then as far as it extends out, it's called the platform, the part that's buried. And the reason it's called a shield, if you think of think of a Captain America's shield kind of from the side, how it kind of like lumps up like that. That's why it's called a shield. So going back here, so the Canadian shield is some of the oldest rocks, not only in North America that make up our continent, but actually in the world as well. But you can see these shield rocks and then the buried platforms that extend out from each of those. A shield and its platform in total is called a craton. Okay, the craton. So because the shield and the platform, but underneath the platform, underneath that all that buried sediment is still the shield. So the area that's the shield and then the platform, the covered shield, all of that is considered a craton, which is considered a continent's nucleus, beginning, starting point. Along the margins or edges of these cratons, more crust was added on that brought it to the size and shape that we see today. Excuse me. Both Archean as well as a little bit later Proterozoic rocks are present in cratons, but they are evidence, and they show evidence of deformation, igneous activity, metamorphism, mountain building. But the craton itself, the old rock, the shield and the platform, or the rocks underneath the sediment, they've really experienced little deformation since the Precambrian. After they maybe were created, that they've kind of pretty much stayed solid. All right, but everything added onto it kind of has changed shape and deformed and any number of things. So again, the North American craton, that includes the shield and platform, the buried part. So this is the kind of ancient nucleus, the beginnings of the North American continent, and all this other stuff was kind of added on. All right, all this other stuff was kind of added on. Focusing on the North American continent, the craton itself again remained pretty stable. After the Precambrian, really not much has changed about it. All of this green stuff has been added on to the North American craton. So North America evolved by the amalgamation, that's the coming together of different pieces of Archean cratons that served, again, as that nucleus around which younger continental crust was added. So the craton itself is actually made up of smaller cratonic pieces, but that's after all of those kind of came together, that's considered that nucleus of North America, of which little has changed. Drilling, as well as other geophysical evidence, indicates that the Precambrian basement rocks underlie much of North America. That's the platform, the buried part of the shield, the buried part of the craton. And it's only exposed in places where there was deep erosion. For instance, the Grand Canyon, as due to the principle of superposition, the oldest stuff's at the bottom. Some of those basement rocks down there are some of these old Precambrian rocks that have been exposed, but that was only there because, well, we can only see them because of that erosion, that weathering and erosion process. So to get to these buried shield rocks, these old rocks, we either have to go down to them, like in the Grand Canyon, or wait for them to be pushed up, like what we see around us at Estrella Mountain Community College here. We have the White Tanks and the Estrella Mountains. Both consist of very old Precambrian rocks that, due to plate tectonics, were uplifted. So the exposed part of the North American craton is known as the Canadian Shield. It occupies a large part of Canada, kind of the Great Lakes surrounding area as well. Again, consists of Archean and Proterozoic rocks, and in places that are thinly covered by glacial deposits, but for the most part, that Canadian Shield is pretty well exposed, and you have some surface coverings, but nothing too crazy. Also, the Canadian Shield constitutes the largest mass of exposed Precambrian rock on Earth. On Earth. All right, so the Canadian Shield, that's that pink stuff here. So this is all old exposed Precambrian rock. Now, if you remember, a number of units back, I talked about the oldest rocks on Earth, the Acosta gneiss, and those are located in northern Canada. I was going to give extra credit for anyone who went there. I don't think anybody did. But the Acosta gneiss is in kind of this area, kind of between these two lakes. Let's see how that matches up. So if a craton is the oldest rocks of the continent, and the shield is the exposed part of that, which the Acosta gneiss is, then if this is the oldest rocks in the oldest parts of Canada, it should be in the exposed shield. So let's see, where is it at in Canada? There it is, it's in the pink, right there, perfect. So that matches up. So the oldest rock is exposed in the pink stuff. Now, not all of the rock here is as old as the Acosta gneiss, which is almost 4 billion years old. It's just this happens to be the oldest here. But all of this is kind of really old, ancient Precambrian rock. Only 22% of Earth's exposed Precambrian crust is Archean. A lot of the other stuff is from the Proterozoic. The most common rocks associated with the Archean that we find are granite gneiss complexes, combinations of granite and gneiss in certain areas. Remember, granite is an intrusive plutonic igneous rock. That's what makes up the majority of continental crust. But gneiss is metamorphosed granite. So in areas where this granite has undergone, typically at convergent boundaries, a lot of heat, a lot of pressure, regional metamorphism, that some of that granite turns to gneiss. So that's why they're called granite gneiss complexes. You find kind of a little bit of each in these areas. Other rocks that we find from the Archean eon range from peridotite, which is very mafic igneous rock, to various sedimentary rocks, but oftentimes which have undergone metamorphism. And then finally, some Archean rocks that we find are these things called greenstone belts. A little bit more, I think, in section 4 on greenstone belts. But we find about 10% of the Archean rocks we find are these greenstone belts. They have their own interesting geology, and they really help us to uncover Archean tectonic activity, what's occurred tectonically during the Archean. So we'll kind of dedicate a whole other section to those. So just a little flavor of the Archean eon and what we found and can expect from there. So when we come back, So we'll pause. When we come back in section 3, we're going to look at plate tectonics in the Archean eon. See you back here in just a second.